Hello everyone, and welcome to this exciting tutorial on implementing jumping and gravity in 3D environments using Java. Today, we will dive deep into the physics of jumping, understand how gravity works, and see how to implement this in a simple 3D game. So buckle up and get ready. Before we start coding, let's briefly discuss the concepts of jumping and gravity. In most games, jumping involves applying an upward force to an object, while gravity continuously pulls that object downward. In 3D space, we often work with a coordinate system that includes x, y, and z-axis. Here, y typically represents the vertical axis. There are a couple of key components we need to set up in our Java project. We're assuming you have a basic 3D engine or library, such as libgdx, set up. If you haven't done this yet, please make sure to install libgdx or any other chosen framework to work with 3D graphics and physics. First, we'll create a class to represent our player. This class will manage the player's position, apply forces for jumping, and handle gravity. Let's start with the player class. In this player class, we have a position and velocity represented by vector3. We defined a constant for gravity and the jump strength. The update method adjusts the player's position based on the current velocity, while the jump function initiates the jumping motion by setting the upward velocity. Next, let's look at how to handle the input for jumping. We will need to detect when the jump key is pressed and trigger the jump action. Here is a sample input handling function that you can integrate into your game loop. In this code snippet, we check if the space key has been pressed, and if so, we call the jump method from our player class. This establishes the connection between player input and the jumping action. Now that we have set up jumping mechanics, let's discuss how to detect when the player has landed. We need to reset the jumping state when the player hits the ground. One way to achieve this is to check the y-coordinate of the player's position and determine if it reaches the ground level. In the update method, we check if the position's y-coordinate has fallen below 0. If it has, we correct the position to ground level and mark the player as landed. Next, let's integrate this jumping mechanics into our game loop. Your main game loop typically involves continuous updates based on elapsed time. Here is how you can do that. Within this render function, we first calculate the elapsed time since the last frame and call our input handler. Then, we update the player's state before rendering the frame. Make sure to include your rendering logic where indicated. To visualize this properly, we should have a simple ground plane or surface for the player to jump onto. Let's create that in our scene setup. Assuming you have a basic 3D environment setup, here's how you can create a simple ground plane. In this example, we create a flat rectangular plane as the ground with a simple color. You can modify the size based on your scene requirements. Remember to add this ground to your rendering scene when you set everything up. Now, let's discuss the concept of friction and how it can affect jumping. If the player is running, we may want to implement some form of horizontal movement. We need to integrate this into our update method to allow lateral motion as follows. Here, we check if the left or right arrow keys are pressed and update the horizontal velocity accordingly. If neither key is pressed, we reset the horizontal velocity to 0 to stop the player's lateral motion. To make our jumping more realistic, we want to factor in the time of flight. This means allowing players to jump higher or lower based on how long the jump key is held. We can adjust our jump method like so. In this modification, we gradually increase the jump strength the longer the jump button is held down, allowing for varying jump heights based on input duration. This creates a more dynamic jumping experience. Now that we have the jump mechanics sorted, we need to make sure it works smoothly with the gravity effect throughout the jump. Let's implement a function to smooth out transitions when jumping and falling. In this code, we ensure that the velocity doesn't exceed a certain maximum fall speed, which gives a more realistic falling experience. Adjust max_d based on the gameplay feel you want to achieve. Next, let's briefly discuss debugging your jump and gravity implementation. If your player isn't jumping correctly or falling through the ground, consider adding logs to check the position and velocity values during each frame. It's also crucial to test how the player interacts with different surfaces or slopes. You may want to implement additional collision detection and response to manage these interactions properly. Finally, let's talk about how you can expand this system. You might add double jumping, extra jump power-ups, or different jumping mechanisms based on the player state. Additionally, consider applying more advanced physics using libraries such as Bullet Physics or JBullet for better realism in gravity and collisions handling. This could provide a lot of exciting gameplay mechanics. And that's it for today's tutorial on implementing jumping and gravity in 3D using Java. Remember to experiment with the values and settings we discussed to find what works best for your game. Don't forget to subscribe and hit the bell icon for more game development tutorials. Thanks for watching, and happy coding!